Hey everybody, this is Mr. McKee again with SEC 210. Today I'm going over Lab 21.2.10, which is encrypting and de-encrypting data using OpenSSL. Alright, if you're in my course, notice here the lab contains 7 questions to answer. So answer those and submit the Word document that's attached to your submission link in Moodle and submit that for grading. Alright, so OpenSSL is an open source project that provides a robust, commercial grade and full featured toolkit for the transport layer security or TLS and secure sockets layer protocols. It is also a general purpose cryptography library. In this lab, you will use OpenSSL to encrypt and decrypt text messages. Note, while OpenSSL is the de facto cryptography library today, the use presented in this lab is not recommended for robust protection. Below are the 2 security problems with this lab. The methods described in this lab uses a weak key derivation function, or it derives a weak key, is what that means. The only security is introduced by a very strong password. The method described in this lab does not guarantee the integrity of the text file. Alright, I'm going to be using a pretty weak password anyways. Alright, this lab should be used for instructional purposes only. The methods presented here should not be used for secure, truly sensitive data. Alright, so you need a CBROPS workstation VM. I'm running mine in VMware Workstation. Alright, so first thing, encrypting messages with OpenSSL. OpenSSL can be used as a standalone tool for encryption. While many encryption algorithms can be used, this lab focuses on AES. To use AES to encrypt a text file directly from the command line using OpenSSL, the following steps follow the steps below. Alright, so we're going to first encrypt a text file. Alright, so I'm already logged on to my CBROPS workstation VM. I'm going to open up a terminal, and I'm going to zoom in some so you guys can see this easier. Zoom in. Alright, so that should be good. Alright, so because the text file is encrypted in the home analyst lab support files directory, change to that directory. And what it means, I think it means we're actually going to be accessing a text file that's not encrypted yet. Alright, so we're CD, we're doing a dot to back up, and lab support files. Alright, so we're in that directory. Alright, so then it wants us to use cat and display letterdigramall.txt. And if your VM looks a little different than mine, don't worry, because I've been using this a couple times to test this lab. Alright, so there you go. And if you remember on the previous lab, you probably changed grandma to grandpa, so you might want to change that back in Nano. Go into Nano just like this, Nano letter to grandma.txt. Alright, so in there, I can go over to grandpa and make it grandma. In my case, I'm not making any changes though, so I'm going to Control X. Since I didn't mess with it, I'm going to say no to my buffer. You would say yes to save yours. Alright, buffer's just saving it to the file. Alright. So what I'm going to do, I'm going to clear all that stuff. I'm going to go back to cat. Alright, so there's my letter. Alright, displaying my text file using cat in my terminal. Alright, so from the same terminal window, issue the command below to encrypt the text file. The command will use AES 256 to encrypt the text file and save the encrypted version as message.enc. OpenSSL will ask for a password and for a password confirmation. Provide the password as requested and be sure to remember the password. I'm actually going to just use the password, alright, all lowercase. So that's definitely not secure. So OpenSSL AS-256-CBC, if I type it correctly, CBC. And also, now what I'm doing is I'm going to do the in function, so -in, and that's the plain text file I'm putting in, which is letterdigramall.txt. Alright, on the next line, well, mine went down to the next line, but I'm not hitting it in return or anything like that. All right, so the next option is the out, which is your output. So you're putting this out to a file named message.enc. If you already have that file, it's going to overwrite it. If you don't have that file currently, it's going to create that file. All right, it's going to ask for a password. I'm going to use password as the password. All right, let's double check you're typing it incorrectly. So I'm typing the password twice. You get the warning that it's a weak key now, that it can be cracked fairly easily. All right. Now in my instructions, I put an answer for document password. You can just put your password in there if you want. That's not a big deal. All right. So when the process is finished, use cat command again to display the contents of message.enc. Now what we're doing is it's saying use the cat command again to display the contents. Message.enc is not the original letter to grandma.txt. That file's still there. So if I do ls to list it, notice letter to grandma.txt is right there, but we've created a new file that's encrypted right there called message.enc. Right. I'm going to go ahead and clear the screen again. All right, so it wants us to use cat and display message.enc. And notice it displays it with like hidden characters. All right. So did the contents of message.enc file display correctly? And I guess they're saying did it display as it should in plain text. Well, you guys can tell that that's not the case. All right. What does it look like? You can explain that. So the first answer one there, did it display correctly? You can explain that. What does it look like? You can say it looks kind of like, hidden file, hidden characters, things like that. All right. So I'm going to go ahead and clear that again. All right. So to make the file readable, run the OpenSSL command again, but this time add the A option. The A option tells OpenSSL to encode the encrypted message using a different encoding method of base 64 before storing the results in a file. Okay, so what it's going to do here, and it says note base 64 is a group of similar binary to text encoding schemes used to represent binary data in a ASCII string format. All right, I'll show you guys what that means too, by the way. All right, but what we're doing now is we're using OpenSSL. We're going to encrypt it again using the A option in letter to grandma and then out. But actually, we're going to save the output as base 64. So you can say that's encrypted, but it's really not encrypted. But I'll show you guys what I mean. And if I can type correctly, OpenSSL AS-256-CBC-A. So the difference is we're putting the A option in there. So once again, the input file we're going to use is letter to grandma. And remember, that's still a valid plain text file. Now the out is going to go to message.enc. So since we created that file the last step, so that it's going to overwrite that. What did I do? Yeah, if you type it incorrectly, it's not going to work. All right, so to ask for the password. All right, so I'm going to use password again, but we're literally overwriting the existing file, so you can use a different password. I'm going to use password again. I'm going to verify it. All right, it tells me the warning again. Don't worry about that. But now we're going to look at the contents using cat message.enc. And now notice here, let's see if it shows the same. PW. See, something's different about the instructions than my file, because if you notice, the first characters are the same, but then you get down there to the very end, where it has the equal sign, it's different. Not a big deal in our case, because I don't know, I might have pushed enter or something like that in the file when I edited it. But what I want you guys to understand though, if we're looking here, all right, this is in base 64 encoding. It's not really encrypted, but what it's doing is this right here. Here's my spreadsheet. And if you guys are any of my networking classes, you notice I did like a hex to binary conversion for like a MAC address or IPv4 to subnetting and stuff like that, or IPv6. But all that stuff really doesn't matter right now. Base 64. This isn't the best looking explanation, but I just copied this over. It's kind of hard to find a base 64 to ASCII and binary conversion, because online it just literally converts it for you. But I want to show you guys what it's doing. All right, if you look right here, and I know it's hard if I can zoom in. All right, this is what I'm actually showing, and none of this is calculating. I'm just using this as representation. All right, my plain text, like if I did a message that said hi with an uppercase H, lowercase I, a space, then uppercase T, lowercase H-E-R-E. All right, so that's my plain text. All right, now I can represent that with ASCII characters, and notice I'm skipping binary, but ASCII 72, 105, those correspond to the characters at the top row. All right, so if I zoom back out, on my right side, this is my ASCII to binary and plain text converter. I'll call it that. All right, and this needs to be shrunk a little bit more. All right, so if I look at uppercase H, if I go over here and follow down the columns, uppercase H is right there. So that's the same thing as the letter uppercase H, the same thing as 72 in ASCII. All right, don't worry about the leading 0. That's fine. All right, but notice right there, and then binary 01, 001, 000. All right, notice 8-bit binary code. All right, so plain text, uppercase H, binary is right there, ASCII. All right, so base 64 is a little bit different. Base 64 is in 6 bits, not 8 bits, like ASCII is. All right, so I'm going to zoom in, and this is where it gets tricky. But if you look at, and I just put base 64, that looks like a function, but I just put base 64, that's the, I guess I could put 6-bit. I guess I could do that. Make a little bit more sense. All right, that's putting 6 bits, and what I'm referring to, each of these 6 bits, they're different colors. That's where I'm getting these letters. And this might not make any sense, because obviously they're different letters. All right, but what it's doing is base 64 is 6-bit. All right, so I'm going to zoom out. So I'll look here, H in plain text. If I follow it in, on my left side is my base 64 alphabet, and notice there's 64 possible characters. All right, it goes from 0 to 63. All right, if I look over here and I go uppercase H, I follow it down to uppercase H. All right. Notice that is, let's see. All right, so all I did really was take the binary 8-bit and copy it down here for each of those. All right, so those are all one-to-one relationships without the highlighting. But when I look at the highlighting though, if I go over here and say, okay, uppercase H is right here. Where's my H? And let me make sure I get this right now. Right, that's H, binary, so bring it down there. And I say, okay, so I'm going to add up these 6 bits. So right down here, notice this doesn't really calculate it. That's just 6 bits in binary. So if I put the actual binary values, would be 0, 1, 0, 0, 1, 0. If you're counting by binary, first first column starting from the right is 1, 2, 4, 8, 16, 32, and so on. All right, so we're stopping at 6. So in my case, 010011 is my first base 64 letter. So if I add that up, 16, I have one in the 16 column and one in the 2 column. So that'd be 18. So if I fall over here, 18 and base 64 equals S. So I'll put an S down here. All right. And the second thing, since it's an extra 2 bits left over there, I have 0, 0, and then in the next column, I'll call these each columns where all the characters are. But you have 0, 0, and then a 0, 1, 1, 0. So if I brought that down here, 0, 0, 0, 1, 1, whoops, 1, 0. All right, so let me make sure I got that right. This is kind of tricky. All right, so I have one in the 4 column and one in the 2 column. So that would be 6. So over here on base 64, 6 is equal to G. All right. So far I have S and I have G. And notice right here, 6 bits ends right in the center. So any of these that I did that when they the 6 bits end in the center, I just put the first character and the second character with a little dash in between it, but just disregard the dash. All right, so the third character would be 1, 0, 0, 1, 0, 0. 1, 0, 0, 1, 0, 0. So that would be, let me double check it. All right, so 32, the 32 column is 1, 4 column is 1, and that's it, right? Yep. All right, so that should be 36. So 36 over here is K, all right? So I'll put a K there, all right? So follow these down. I can do the same thing. I'm not going to do these for all of them, but basically this is I wouldn't call this is not encrypted. This is encoded. You're taking plain text, and instead of encoding it in ASCII numbers or codes, you're encoding it as base 64. And they do this for like email messages where it's just text to make sure they don't get, I guess you call it out of sync. You're not like, you don't have like extra values, like extra bits laying out there. And what they do is, if you notice here, each 3 characters, it has to have exactly 3 characters. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, and we don't have 3 characters. All right, so if you're missing a character, you're either going to put an equal sign or 2 equals. And what happens is, if you notice this, my last full character only has 4 bits, which can get kind of confusing, but just think of that. That would be the same thing as 0. Let me make sure I don't get this incorrect. 0, 1, 0, 1, and then just 2 trailing zeros. All right, so that'd be the same thing as having 0, 0 out there on the end. And I gotta make this. Let me make this format as text. All right, so we'll keep my zeros there. All right, same thing as that. All right, I know that's super confusing, but 0, 1, 0, 1. All right, so that's 20. That's going to be 20. So if I follow 20 down, that's U. Okay, notice I don't have anything left over. I don't have exactly 3 characters, and in base 64 you have to have 3 characters. All right, so 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2. So you have to put an equal sign that just shows that you put a placeholder in there. All right. And if you had, say if I had 1 character less, like if I had, say if I had uppercase HI and it didn't have a space there, I'd have to take that out and it'd have 2 equal signs. All right, but that's why it's that. It looks like that. So what we're looking at, I know that might be super confusing, but it's cool to understand what's happening. This isn't actually encrypted. This is just encoded using base 64. So if you looked at this and you said, okay, you, let me bring this back over here, you should be, let me see if I can do this from memory. This is why a calculator is good to actually do it, but starting out with you, so if I had you here, let's see if I can do you. You would be the same thing as 20. So to do 20, let's see, 20 would be 116 and 14. So it should be, this should be the same thing as 0, 1, 0, 1, 0, 0, 0, 0. All right, so if I go over to take that number 0, 1, 0, 1, if I did that correctly, it should be a P. Let's see if I got it right. No, it's saying I. Maybe I have that. U2. Let's see, if I did it right, I would have H. Zero one 1 0 0 1 0 0 1. Should be an H on the beginning. Okay, I see what it's doing now. It's actually, it's encrypting it, and then it's making it base 64 encoding in it. So if we didn't encrypt it, if we just used a if we just used plain text and did a base 64, it would come out correctly. All right, just like I'm showing you guys, but don't really worry about that. That just shows you how the base 64 works. But what they're doing is, it's super hard to decrypt that without the key, because they're taking that output that looked like question marks inside of like random keys, basically question marks inside of diamonds and stuff like that, and question marks, and they're encoding that in base 64. So it's easier to, I guess, easier to transport it like that, because you get a set output just like this. All right, so you can kind of like copy that instead of what we saw before. So that, I guess it's better. It's easier portable like that. But if you're going to do just plain text, you would do it the way I showed you guys how to do that, base 64. So if you received a email that was encrypted, you'd have to have the key to decrypt it. But if you got an email, just a basic email, its text is going to be encoded with base 64. All right, so you can decode that if you don't have a decoder from scratch. And the reason you have the equals on the end, because say if this is one sentence, the next sentence, you'd start mixing things up if you didn't have exactly the right amount of characters. All right. Not a computer scientist, but yeah, that's how that works. I just learned that from like cybersecurity kind of stuff. All right. But anyways, let's keep going. I'm getting off task. All right. So is ENC displayed correctly now? I would say it is, but it's can you think of a benefit of having message.enc base 64 encoded? I mean, it's more portable. You can copy and paste that. You can't copy and paste the way it was before it was encoded at base 64. All right, but now we're going to decrypt the messages. And what I'm going to do is I'm going to go ahead and clear the screen. All right, so we're going to do OpenSSL AES 256. -cbc a d. All right, so now we're taking a base64 encoded message and then we're decoding it. So up here, base64 encoding it, right? And we're decoding it, but now our input is going to be the message.enc and the output is going to be to not overwrite our original letter, but we're going to create another file with it decoded. More or less for safety in case you mess it up. You're not going to lose your original file. All right, decrypted CRYPTD underscore letter TXT. All right, password is password. All right, so if you didn't know the password, you couldn't get into it. All right, so now we're going to actually display the newly created decrypted letter. All right, so we're there. That looks like the original message. It could be altered, but it's not. All right, so that shows you. All right, was the letter decrypted correctly? I would say yes. The command used to decrypt also contains the A option. Remember the A option? Follow that up here. All right, to make the file readable, this time use the A option. The A option tells OpenSSL to encode the encrypted message using a different encoding method of base64 before storing the results in a file. All right, makes it way more portable, so I can copy and paste that. All right, but that's it. Quick video. Hope you guys, if you're going to get into cybersecurity, you're probably definitely going to use this or need to know that, but that's basically ASCII to base64 converter. I would recommend, some people ask me to upload the stuff like this that I do, but I mean, I would just go online and kind of like make your own because you start to understand it when you do it. But basically, base64 starts with 0 value, and that's uppercase A. It goes all the way down there through the alphabet in uppercase. Then it switches over to lowercase. And notice 25 is Z. There's 26 letters in the alphabet, but 0 is the first number. All right. All right. And then 26 starts with lowercase a, goes through lowercase z, and 51. All right. And then you have all your numbers. You have plus, and then a slash, and then the equals is for padding. And remember, if all these aren't in sets of 3, you're going to need padding. If it has 1 left over, you need 2 equals. If it has 2 left over, you'll need 1 equals. All right, but that's it. And then ASCII is pretty common. But these are some of the ASCII characters. Now ASCII has a whole bunch of different characters, but that's just the letters, uppercase, lowercase letters. All right, but that's it. Pretty quick video. Hope I didn't go too far into stuff and get off on a tangent, but I think it's pretty interesting how that actually works. I've done a lot of Wireshark, and you do packet capture analysis, and understanding what you're looking at goes a long way. Maybe you can't decode it, but you at least know you're able to identify a base64 encoded message. All right, that's it. Thanks for watching.